Welcome to Chapter 11. This is Section 1. In this section, we're going to do a couple of things. First, we're going to learn how to use what's called the square root property to solve a quadratic equation. So thus far, the only way that you know how to solve a quadratic equation is by factoring. But what you'll find is that not every quadratic equation always factors. So we need some more techniques for solving quadratic equations. So the first one we'll learn is how to use the square root property. The next one we're going to learn in the next section is how to use what's called the quadratic formula. And that's a great formula that's very, very useful. So can't wait to get to that. But first we have to learn how to complete the square also in this section before we can get to that quadratic formula. So you're going to, in the end, have three major methods for solving quadratic equations like this. You'll have factoring, if it works. Then you'll have the square root property the square root property and the completing the square are related. That's why they're both in this section. So there's completing the square root property is the second method, and then third we'll have the quadratic formula. Okay, so let's get started by looking at an example. Let's solve this equation x squared equals 16 two ways. First by factoring, and then we're going to do it by using the square root property. Okay, so to solve this by factoring, as you know, it's a quadratic because the highest power is 2. So the first step is to get one side equal to 0. So we'll do that by subtracting 16 from both sides. And then factor. This is a difference of squares. This is equivalent to x squared minus 4 squared. So it's going to factor into x plus 4 times x minus 4. And once you get an equation that's factored and set it equal to 0 on the other side, you can use that zero product principle and set each factor equal to 0 and solve for x on each of those. So this gives us x equals negative 4 and x equals 4. And of course you can check. If you plug in negative 4 up here into the original equation, negative 4 squared is 16, and also 4 squared is 16. So those are the two solutions to this equation by factoring. Now there's another way to do it, and that's called using the square root property. The square root property is what you use when you take the square root of both sides. So because it's of the form something squared equals a number, the other way to solve it is to take the square root of both sides. And any time you take the square root of a variable squared, such as right here, you've got to put a plus or a minus on the other side. Because on the other side we have square root of 16, which is 4. Now if we had forgotten that plus or minus, we would have just said x equals 4. And that's not right. That's not the only solution. Okay, there's two solutions, x equals positive 4 and x equals negative 4. So you do need that plus or minus. So remember to always put a plus or minus on the other side if you ever take the square root of a variable squared. Okay, so those are the two solutions found by using the square root property. And as you can see, this second method was a bit quicker, a bit more easy, so oftentimes I'll go with the square root property when I have something of this form, a variable squared equals a number. Okay, so more generally, what does the square root property say? It says if b is a real number, and if a squared equals b, then if you take the square root of both sides of this equation, you'll get a equals plus or minus the square root of b. That's what happens when you take the square root of both sides of this equation right here. Okay, so that's how you can solve for a. So let's use that in another example to solve x squared equals 20. So taking the square root of both sides gives us x equals plus or minus the square root of 20. And now we have to figure out if that simplifies. Let's go over here to the side. 20 is divisible by 2 is 10, divides by 2 is 5. So we can pull out a 2. So there are two solutions, positive or negative 2 radical 5. Okay, now that is, it's good that we solved this one this way because if you'll notice, if you move the 20 over and try to factor, that's not factorable. So this is one where you really have to use this square root property because you can't factor it. Okay, so there's plenty of quadratic equations that are not factorable. This is just one. Okay, let's use we're going to use the same principle for all of these, the square root property, to solve 5x squared minus 55 equals 0. Well, before you use the square root property, you want to get it in this form to say something squared equals something. So we need this square, that x squared, by itself on one side first. So first we're going to move the 55 over. Now notice it says if a squared equals b. It doesn't say if 5a squared equals b. So we also have to get rid of that 5. But that's easy to do. We can just divide both sides by 5 to get x squared equals 11. Now it's of this form, a squared equals b. So we can take the square root of both sides to get x equals plus or minus the square root of 11. And 11 is prime, so that's not going to simplify any further. Okay, this next example, we're building up here to completing the square. And this next example is sort of it's one like what you'll see when you complete the square. Now it's of a different form. It's of x plus 2 all squared equals 18. Okay, it's still of the form a squared equals b, where a corresponds to x plus 2. And b would correspond to 18. So you can still use the square root property and take the square root of both sides. So if I take the square root of x plus 2 all squared equals the square root of 18. Now you do have to remember we have a variable here being squared all underneath a radical. So we automatically have to put a plus or a minus on the other side. And then from here we want to solve for x. So all we need to do is subtract 2 from both sides. And we also need to simplify the square root of 18. So over here, let's see, 18 divides by 2 to get 9, divides by 3 to get 3. So I can pull a 3 out. So we have x equals, if I move that 2 over, we'd have negative 2 plus or minus the square root of 18, which is 2 radical 3. So those are the two solutions to this equation. And next here's another one very similar to this one. But before you get too started on it, look at it closely. You're looking for values of x so that when you have this quantity 3x minus 1 and you square it, you get negative 4. Now can you think of any number so that when you square it you'll ever get a negative number? And the answer should be no. There's no number, well, no real numbers here we're focusing on, squared so that when you square them you get negative 4. But let's go ahead and solve it anyways because we do now know how to deal with complex numbers. So now that you know how to deal with complex numbers, we can actually go ahead and solve this anyways. So let's take the square root of both sides. Now on the left, square root and square cancel, and there's a variable being squared under a radical. So we'll put a plus or minus on the other side. Now the square root of negative 4, you now know that you can write that as 2i. Because the square root of 4 is 2, and that negative that's under the radical becomes this I. And so from here we can keep on solving for x by adding 1 to both sides. So we get 3x equals 1 plus or minus 2i. And to get x by itself, we just need to divide both sides by 3 to get x equals 1 plus or minus 2i, all divided by 3. Now you can leave it like this, or if you wanted to write it in that a plus bi form, you could split it into two fractions, 1/3 plus or minus 2/3 times I. That's in the standard form a plus bi. But those are both correct solutions for this equation. Now notice there's no real solutions, but there are imaginary solutions. And you might wonder why in the world you would want to find that and who would care if there's imaginary solutions. But it goes back to what I was saying in one of the previous videos about how when you're dealing with complex applied problems, oftentimes you start with a real number problem and the solution is a real number, but you do have to go through these imaginary numbers to get there. So we're sort of learning the baby steps for getting to such applied problems right now, but they really are useful. Okay, so that's it for using the square root property. Now what we're going to do is build on that and learn how to solve a quadratic equation such as this by doing what's called completing the square. Okay, so how do you complete the square? Well, before we do that, we actually need to look at what are some perfect square trinomials. Perfect square trinomials are trinomials such as these: x squared plus 8x plus 16. Now that's considered a perfect square because if you factor it, you can write it as a perfect square factor. Now let's see how you would factor this. Let's write it out. The x squared would become an x and an x. The 16 you could write as positive 4 and positive 4. And if you FOIL this back out, you'll get for the outside terms 4x and for the inside terms 4x, which do add to 8x. Because they're the exact same, x plus 4 times x plus 4, you can write this as x plus 4 all squared. So that's why this is a perfect square trinomial, because it factors into something that is a perfect square, x plus 4 all squared. Okay, another example would be something like x squared minus 6x plus 9. That one would factor into x minus 3 all squared. So if you write out x minus 3 times x minus 3 and you FOIL it all out, you'll get x squared minus 6x plus 9. Okay, another such example would be something like x squared plus 3x plus 9/4. Okay, how did I get that? You're going to learn in this upcoming section. Okay, but that would actually factor into x plus 3/2 all squared. Because for your outside terms you would have 3/2 x. For your inside terms you'd have 3/2 x. 3/2 plus 3/2 does equal 3. And then your last two terms are 3/2 times 3/2, which does give you 9/4. Okay, so those are perfect square trinomials. Now completing the square is accomplished when you write a quadratic equation so that one side is a perfect square trinomial. So completing the square is accomplished by writing one side of a quadratic equation as a perfect square trinomial. Because once you write one side as a perfect square trinomial, what you can then do is take the square root of both sides, just like we did up here on these two examples. You can take the square root of both sides using the square root property and very easily solve for x. Okay, so it's easier said than done though, writing one side as a perfect square trinomial. These are the steps for doing it. These can be found in your book on page 649, or you can pause this video and write them down. Okay, on the first few examples we're going to do the coefficient of the x squared term is going to be 1. That makes it a bit easier to do. So the first few examples you'll actually skip step 1 and you'll go straight to step 2, which is to isolate the variable terms, that is the terms with x's, on one side of the equation. So your variable terms are the terms with x's. And then any terms that don't have x's in them all should go on the other side of the equation. So let's go one step at a time through this. Let's start here with step 2 because the coefficient of the b squared here is 1, so we'll skip step 1. Okay, so this one actually is already done. Step 2 is done for us because the 3 is already on one side and both of the terms that have a b are by themselves on the other side. So step 1 and step 2 are done for us. Okay, so we're actually going to jump to step 3 in this example, which is to complete the square for the resulting binomial, that's these two terms on the left, by adding the square of half the coefficient of x to both sides of the equation. Now I know you're saying, what? Okay, but it's not that hard. What you do is you take the coefficient of the b term, or just the simple x term, not the x squared term, but the other term, the b term, the x term. In this case it's positive 4 is that term. So you take positive 4, you always divide it by 2, whatever that number is you'll divide it by 2. In this case that gives us 2. Next we square whatever we get. I ended up with 2, so now I'm going to square it to get 4. Okay, so let me write this out over here in sort of more easy to understand terms. It is to divide the coefficient of x, or whatever your variable is, by 2, then you square it, whatever you get. And then that is what you're going to add to both sides. Okay, so our magic number here is 4. So we're going to add 4 to both sides of this equation up here. So we have b squared plus 4b. Now let's add 4. And that's equal to 3 plus 4. Remember, you can only do something to equate an equation if you do it to both sides. What you do to one side, you must do to the other. So we have to add 4 to both sides. Now, what's on the left side should be a perfect square. So we can go to step 4. Step 4 says, factor the resulting perfect square trinomial, that's what's on the left, and write it as the square of a binomial. So let's see, how does b squared plus 4b plus 4 factor? Looks like it will factor into b plus 2 all squared. And on the right side, 3 plus 4 is 7. Okay, now this number that goes right here, how do I know what to put there? It's always going to be this number. Whatever you get when you divide the original coefficient of b by 2 is what will go here, and that includes the positive or negative sign. Okay, then the last step is, now that we've got it written in this form, do what we were doing before and take the square root of both sides using that square root property. So this is step 5. We'll take the square root of both sides. And on the left, the square and square root cancel, but we did have a variable squared under a radical, so we have a plus or minus on the other side, and square root of 7, which does not simplify. But that's okay. To solve for b, all we have to do is subtract 2 from both sides. So we get negative 2 plus or minus radical 7. Now those are some crazy answers compared to probably what you're used to getting. And part of the reason is because if you tried to factor this, it wouldn't factor. If you moved that 3 over, you'll find that there's no way to factor this. So far, this is the only other way you have to solve such an equation that does not factor. Okay, now let's check our answers on this one. Let's do that by first approximating these two solutions, and then I'm going to show you how to check your solutions. Okay, so there's two solutions here, really. One of them is negative 2 plus radical 7. The other one is negative 2 minus radical 7. We've just written them in one line up here by putting that plus or minus. So approximating those, let's see, negative 2 plus the square root of 7 approximates to, carry it out to a few decimals. Always go out more decimals than you think you need, just to be on the safe side. So about 0.645751 is what I get. And then for negative 2 minus the square root of 7, I get approximately negative 4.64575. Okay, so let's check. Now I'm going to show you two ways to check. I'll do one way with this first solution and the other way with the other solution. Okay, one way to check is to use the approximated version of the answer. So one way is to use the approximated answer. To do that, you'll need a calculator. To do the other method, you won't need a calculator. So you would plug it in. You want to go back to the original equation and make sure it solves that original equation. So you would plug that in for b. So if we plugged in 0.645, I'm just going to round here, squared, plus 4 times 0.645, we should get roughly 3, hopefully. Now let's see, if you're reusing the decimal numbers that your calculator gave you, it should give you exactly 3. Now if you're actually retyping 0.645, you're going to have some rounding errors. And let's see, 0.645 squared plus 4 times 0.645. If I retype it, I get 2.996. Now that is approximately 3, which is what I want, and I would expect a little bit of rounding error because I rounded. So basically that shows that yes, that does work. The other way is to check is to use the exact answer. So let's use this method for our other solution, which was -2 minus radical 7 for that one. So let's plug that into the original equation up here. Now if we plug that in, we'll have -2 minus radical 7 all squared plus 4 times -2 minus radical 7. Now hopefully that simplifies to 3. That's what we want to get. So let's see. I'm going to bring this around and down here for space. Now to square that, we'll need to FOIL that out. So it's -2 minus radical 7 times -2 minus radical 7. Then over here we can go ahead and distribute that 4 to get a -8 minus 4 times radical 7. This should simplify quite a bit pretty quickly here. Now when we FOIL this, over here we have -2 times -2, which is +4. Then we have -2 times negative radical 7, which is +2 radical 7. Our inside terms are negative radical 7 minus 2, which is also +2 radical 7. And the last two terms are negative radical 7 times negative radical 7 to give me +7. And then we still have that -8 minus 4 radical 7. And let's see, all the radicals should go away. We have 2 radical 7 plus 2 radical 7 minus 4 radical 7. Those are all like terms, so we can add the coefficients 2 plus 2 minus 4 to get 0. Those all cancel. And then the numbers we're left with are 4 plus 7, that would be 11. Minus 8 does give us 3, so that is correct. So those are two ways you can check your answer using this method. Okay, now let's do another example that is similar to the previous one. We want to solve p squared minus 3p plus 1 equals 0 by completing the square. Okay, so let's review the steps real quick. First, is the coefficient of x squared equal to 1? In this case, yes it is, so we're going to go to step 2, which is to isolate all the variable terms, that is the terms with x's on one side of the equation. So down here, well, we have p's instead of x's, but same way, so we'll put the p's on one side, and we'll do that by just moving the 1 over to the other side of the equation. And then that gives us, that puts us at step 3, just to complete the square for the binomial on the left side by adding the square of half the coefficient of x to both sides. So we take that coefficient of p, now you do include the sign, so the coefficient of p is -3, so we divide that by 2, and then we square the result. -3/2 all squared would be +9/4. So that's what we're going to add to both sides. So we'll have p squared minus 3p plus 9/4 equals -1 plus 9/4. And now the left side should be a perfect square where the number that goes right here next to the p is, as always, it's always going to be that right there, which you get when you divide the coefficient of p by 2. So it should be -3/2 all squared. And if you do FOIL this out, you will get -3p for your middle term, because -3/2 minus 3/2 is -3, and the last term will be -3/2 times itself, which is 9/4. So that does work. And then we simplify what's on the right side, -1 plus 9/4. In my mind, I'm thinking -1, I'm thinking of that as -4/4. So -4/4 plus 9/4 is going to be +5/4. And now we have an equation that is a perfect square on one side, so we can take the square root of both sides. And on the left, the square root and square cancel, and because we're taking the square root of a variable squared, don't forget that plus or minus on the other side. Now on the right, we have the square root of 5/4, and because I can take the square root of 4, I'm going to write that as the square root of 5 over the square root of 4, because that denominator will simplify. So then to solve for p, all we need to do is add 3/2 to both sides. So we get 3/2 plus or minus radical 5/2. And you can leave it like that, or since they both have a denominator of 2, you could also write it as 3 plus or minus radical 5 all over 2. Either way is good. So there's another example of completing the square, and again you can check your answers by plugging them into the original equation and they should both work. Now for an example where the coefficient of x squared is not equal to 1. In this case, the original coefficient is 3. So let's go back to those steps from earlier, and it says step 1. If the coefficient of x squared is not 1, divide both sides of the equation by the coefficient of x squared. So that'll essentially make it into equal to 1. So what we're going to do is divide both whole sides, remember you have to divide the whole entire side, by the leading coefficient. So we'll divide both sides by 3, and then we can split this on the left into 3 separate fractions, 3x squared over 3 minus 12x over 3 plus 1 over 3 equals 0 over 3. Well, 0 over 3 is just 0. Those 3's cancel. 12 over 3 is 4. So we get x squared minus 4x plus 1/3 equals 0. And now we have converted it into an equation whose leading coefficient, that is the coefficient of x squared, is 1. And so from here we follow the normal steps. So we're going to move that 1/3 over to the other side to get it out of the way. And then we take this coefficient of b, which is -4. We divide that by 2, and then we square the result to get 4. So it looks like we're going to be adding 4 to both sides. So we have x squared minus 4x plus 4 equals -1/3 plus 4. So the left side can be factored into x minus 2 all squared. And the right side, we have 4 minus 1/3. 4 you can think of as 12/3, so 12/3 minus 1/3 would be 11/3. And then if we take the square root of both sides, we have x minus 2 equals plus or minus radical 11/3. 11 and 3 are both prime, so that will not simplify. So we get 2 plus or minus the square root of 11/3. Okay, make sure you're pausing this video and try the next one ahead of me without my help. Now because there's a coefficient in front of x squared, we first need to divide both whole sides by that coefficient. So we'll divide both sides by 2. That will give us 2x squared over 2 minus 5x over 2 plus 7 over 2 equals 0 over 2, which is just 0. So we get x squared minus 5/2 x. Now I'm going to go ahead and move that 7/2 over to the other side, equals -7/2. And in fact, what you can do is you can leave a little space here in order to add the term that's going to go next. It'll just save you a little space. So then we take this coefficient over here, divide it by 2. -5/2 all divided by 2. Well, remember that's -5/2 times the reciprocal of the denominator. The reciprocal of 2 is 1/2. So you get -5/4. And then we square that result. When we square -5/4, we get 25 over 16. So that's what we're going to add to both sides. So on the left, it should factor into x plus this number. So minus 5/4 all squared. And if you check, that will work. If you FOIL this out, you should get back this. So you can always check your work here. And on the right side, we're going to need a common denominator. Looks like 16 will work. So I can multiply the first fraction by 8/8 to get a denominator of 16. Negative 7 times 8 is negative 56. So negative 56/16 plus 25/16. And we'll simplify that on the next step. So we have x minus 5/4 all squared equals, let's see, negative 56 plus 25 is negative 31. And then now we can take the square root of both sides. Oh, except look, we have a something squared equals a negative number. That means our answer is going to involve imaginary numbers. So when we take the square root, we have x minus 5/4 equals plus or minus the square root of negative 31/16. Now that negative turns into an I. Square root of 31 is prime, so that does not simplify. And the square root of 16 is 4. So to solve for x, we just add 5/4 to both sides. And it looks a little odd, but this is the answer. 5/4 plus or minus I times radical 31/4. Wow. Okay, next we're going to look at some applied problems. In solving these applied problems, we'll end up using a few of the techniques that we've learned throughout this section. Before we can get to the real applied problems, which is compound interest, let's first talk about simple interest. Simple interest is when typically you're talking about money, some amount of money that is, say, invested or put into an account of some sort earns interest on the original principal that you put in. Okay, this up here is a formula for how to compute the amount of interest that you earn. So I represents the interest earned, P represents the principal, that is the amount invested or saved or put into account or whatever. I just say invested to mean put into some sort of account. R is your interest rate, and that's actually a yearly interest rate. It doesn't really matter. Pretty much any interest rate you see is usually a yearly interest rate. And T represents time in years. Okay, so this makes more sense when we look at an example. So let's just do that. Let's say you invest $100 at an APR. That means that's your interest rate. So that's lowercase r, that's your interest rate of 4%. So the interest rate is 4%. Now remember, if you write a percent as a decimal, you have to move the decimal over 2 places. So as a decimal, that's 0.04. And when we do computations, you want to put in r as a decimal, not as a percentage. So r is 0.04 here. It's for 2 years, so that means t is 2. And let's go back over here. That $100, that's your initial amount invested, so that's P. P is 100. Okay, now it's compounded annually, meaning once per year, and that's what this is about, compounding annually. With simple interest, how much total interest will accrue for 2 years? Okay, let's first do it with the formula, and then I'm going to write it out and show you what's happening in each of the 2 years. So the total interest accrued is I equals PRT. That's your principal, which is 100, times your interest rate, which is 0.04, times the number of years, which is 2, and then you just enter that in a calculator. So 100 times 0.04 times 2 is going to give you 8. So your total interest accrued would be $8. Okay, and here's what's happening. You invest $100 at the beginning of this 2 years. Okay, at the end of year 1, so it has to sit there for a whole year, and at the end of the year you earn a 4% interest rate. Now 4% of $100 is $4. So at the end of 1 year, you earn 4% of your principal of $100 or $4. But we do this for 2 years, so then we do it again. Basically, that money sits there, and then at the end of year 2, you earn another 4% of your $100. So you're only earning interest off the original amount invested this second year. You don't earn interest off the sum of the investment and the previous interest. That's compound interest. Okay, so then the total interest earned is the sum of that interest and that interest, which is $8. And that's exactly what this shortcut formula over here got us. But this is sort of what's really going on behind the scenes. Okay, it's important that you understand that because that'll help you to understand compound interest. So compound interest, like I said, is where you invest some money and then at the end of the first year, you earn your simple interest. Okay, it's the same the first year. So let's say you invest $100 with an APR of 4% compounded annually with compound interest this time. So let's find the total interest accrued and then the total amount of money at the end of 3 years. So the total interest accrued at the end of year 1 is going to be, if it's 4% of the amount there, so it'll be $4. 4% of 100 is $4. So then with compound interest, you add together the original amount plus the interest that you have. So now we have $104 in the account. Okay, and then that comes over here. So now we have $104, and the next time we accrue interest, we add on 4% of 104, which you would probably need a calculator to do. 4% of 104, that would be 0.04 times 104. 0.04 times 104 gives us 4.16. So you would earn $4.16. And then you add that on to what you previously had. So $104 plus the $4.16 will be $108.16. And now we start with that amount, $108.16 at the beginning of year 3. And then at the end of year 3, we earn 4% of that. So 4% of 108.16, you would multiply 0.04 times 108.16. And this time, you just round to the nearest penny when you do this. That's a dollar sign there. You get $4.33 if we round. So now we add on 108.16 plus $4.33 gives us $112.49. Okay, so there's two interesting numbers here. One is how much interest total accrued. Well, the total interest accrued is the sum of the interest each year. So $4 plus $4.16 plus $4.33 is going to be $12.49. And then the other thing to look at is what you have in the end. In the end, the total amount is 112.49. Okay, so those are the two interesting numbers here. This is a shortcut formula that will get you this total amount in the end. It'll give you that 112.49 by just inputting all of the original information into this equation. It's sort of like the I equals PRT, except this one is for compound interest. Okay, this is for compound interest. And the meaning of the variables changes just slightly. P is still the original investment, so that would still be the $100 in this case. R, that's your interest rate per compounding period. which, because we're compounding yearly, R is still your yearly interest rate. Now if you were compounding monthly, R would be your monthly interest rate. Or if you were compounding quarterly, R would be your quarterly interest rate. It would just depend. T is the number of compounding periods, total number of compounding periods. So if you're, for example, compounding once per year for 3 years, then you would have 3 compounding periods. Or if you compounded twice per year for 3 years, you would have a total of 6 compounding periods. So T would be 6. So the meaning of the variables changes a little. It's good to understand that. Okay. Let's get rid of that. Now let's use this formula to basically check what we just did so you can see kind of how it works. Okay, so let's come up here and compute this. Now in this example up here, the P is the initial investment, which is $100. Then it says R is your interest rate per compounding period. Well, we're compounded annually, so interest rate per year is 4%. By the way, APR stands for annual interest rate. Okay, so R is still 0.04, so we have 1 plus 0.04. All right, because I'm looking at that. All to the power of T, where T is the number of compounding periods. Well, if you do it for 3 years and it's compounded once per year, your total number of compounding periods is 3. So you could enter this into a calculator. The way I would enter it is 100 times 1.04 cubed. And when I do that, I get 112.49. Okay, sometimes there might be a slight discrepancy off by a penny doing it this way versus this way because of rounding at each step, but that's going to be pretty darn close. So we got the same thing. Okay, let's do another example so you can see for sure if you're getting it or not. Try this one on your own first. Okay, find the interest rate R. That should say if, little typo there. If $5,000 compounded annually with the compound interest grows to $5,618 in 2 years. All right, this is a different question. It says find the interest rate R. So in this one, we're going to use this formula still, but the goal is to find R, not to find the amount that we'll have in the end. We're actually given the amount that we'll have in the end is 5,618. So the amount in the end is that, 5618. 5,000, that's the initial principal, that's P. R is our interest rate per compounding period, which is we're compounding annually. So that's what we want. We don't know. It says find R. Next variable is T, number of compounding periods. Well, if you compound annually for 2 years, then your number of compounding periods is 2. So plugging all this into this equation up here, we get 5618 equals 5,000 times 1 plus R to the power of 2. And we want to solve this equation for R. Now it looks a little messy just because the numbers are bigger than maybe what you're used to seeing, but it's not any different than anything we've done. We want to solve this for R. We have a perfect square right here. So if we divide both sides by 5,000, then we'll have the square by itself. So 5618 divided by 5,000, if you enter it in your calculator, you're going to get a decimal number, and we don't want to round. So just leave it as 5618 over 5,000. Now you could reduce that probably because these are both even numbers, so I know you can reduce it. But definitely don't round until the very end. Okay, then we have the squared term by itself, so we can take the square root of both sides. So we have on the left, we have square root of 5618 over 5,000. Now on the right we have the square root of a variable squared, which means we also need to put a big plus or minus on the left. And on the right the square root and square cancel to give us just 1 plus R. So to solve for R, all we need to do is subtract 1 from both sides. So reversing the order here, we get R equals -1 plus or minus the square root of 5618 over 5,000. And now this is where you would round, is in your last step. Now you would round this because it is an applied problem. It wouldn't make any sense to give that as an interest rate to anyone. Now if you look at it, we have two answers here. We have -1 plus the radical, and we got -1 minus the radical. Now I can already tell you which one is not the correct answer. An interest rate has to be a positive number. Negative interest rates just don't even make sense. So if you have a negative number minus a number, that's going to be negative. So that cannot possibly actually be R. So it must be this one with the positive. So let's approximate that using a calculator. So I get -1 plus the square root of 5618 over 5,000. And that rounds to, actually it comes out exactly, interestingly, to 0.06. So 0.06 in terms of an interest rate would be 6%. So that's how you could solve for the interest rate using techniques we've learned in this section. Alright, that's it for the applied problems and for completing the square on a quadratic equation.